serve as an introduction to some topics that Marcio will be discussing in great detail in his talk. So if you pay close attention to what I say, you'll probably be able to understand what Marcio is talking about, as he's talking about fixes to the things that I'll be speaking about. All right, so what is Ubik? Ubik is kind of an umbrella term for a low-level facility within OpenAFS that allows it to maintain a database, database in quotes, that is transactional, it's distributed across multiple servers, and it's replicated. So the way that it does that is provides a number of facilities within each of the database servers, which I'll talk about in a second, to allow it to elect a master or a sync site within the machines that are participating in that quorum. It allows it to support file-wide locking so that when an update is occurring, all the servers that are participating in the quorum are locked. Nobody's allowed to do any updates against that. In fact, the current state is that nobody's allowed to do reads against it while it's in that state. It also coordinates commits across the distributed system and makes sure that everybody is able to accept the same commit before it's visible to everyone. And it allows for recovery if in the off chance that there would be a network problem or a server would crash. The Ubik protocol allows each of the database servers to be maintained with the same version of the database. So say, for example, one server goes down and the other two are able to continue with updates. When the third one joins again, and it's discovered that he doesn't have an up-to-date copy of the database, he's fallen behind, then Ubik guarantees that that server will receive updated copy of the database, and then things will proceed as normal beyond that point. You may have noticed that I'm pronouncing it Ubik. I'm not really sure if that's the right pronunciation or not. That's just the pronunciation I've heard. It's actually a term from an old science fiction story, and the title of that story is Ubik, and it's referring to some type of a product that is ubiquitous and provides a lot of different benefits to the people who partake of this product. So the people who wrote this protocol thought that it would be a good name for that because of all the benefits it provides, and it's everywhere. Distributed is the idea from that. All right. And I also want to point out that even though we're always talking about database servers when we talk about the facilities within OpenAFS, like the vlserver, the ptserver, just as I pointed out yesterday, they're not true databases. And the people who wrote this understand that. The reason for calling it a database is because Ubik allows the programmer who's writing facilities on top of Ubik to treat it as if it was a database, using database-like semantics, if that makes sense. All right, so here's some of the design goals when Ubik was first invented out of whole cloth by the people who did the original research and developed OpenAFS back in the 80s and early 90s. First of all, they wanted it to be highly available. So that's the reason for the multiple servers. Not the people who were developing this at Carnegie Mellon knew that the existing technology for hardware back then was not going to be able to support the load that they were going to be putting on these servers if they only had a single server. So that's part of the reason for having multiple servers. The other reason, of course, is for not just for load sharing, but also for resiliency. If one should go down, it won't block the entire cell from doing reads or writes. The next thing is that no partial or incomplete commits are going to be seen by the users if they're following the protocol. It's non-blocking, unlike two-phase commit, which will block if a member is out of service. You won't be able to do any more writes anymore. Ubik was designed in particular to allow writes to continue to happen even if a server should go down or get partitioned from the other two. So that's a unique feature of the protocol. It's consistent in that almost all the time, anybody who goes to any of the members in the set of servers that comprise the quorum does a query against that, they're going to get consistent results no matter which one they copy to, because each one, in normal case, is supposed to have a copy of exactly the same physical copy of the database. The physical idea is something I want to touch on later, but if I forget, please ask a question about that. Because the idea that Ubik manages a physical database is kind of important. And it's supposed to be simple. So there are some design compromises in what Ubik is able to do and how well it works in certain circumstances that were made deliberately for the sake of simplicity of implementation and simplicity for the programmers who wrote applications on top of Ubik. To allow them to write a relatively lightweight piece of code that would support Ubik by making these simplifications. So what are some of the limitations? As I've already hinted, we want to make sure one of the design goals was to keep things simple. So you may have heard the KISS principle, keep it simple, stupid. That's the reason for some of these limitations. First of all, they only support one write transaction at a time, and that is not going to change in the foreseeable future because it simplifies logging and simplifies recovery, and that's the reason that simplification was made. At the time it was written, that was deemed to be sufficient for any load that was going to be happening. The large majority of activity against a vlserver or ptserver is going to be reads, not writes. So one write at a time is almost always enough, even today. Another thing is that no reads during writes. I think Marcio is going to speak a little bit more about that. Excuse me. There's no deadlock detection or protection. The application writer, rather than the Ubik system itself, is responsible for avoiding deadlocks by using locks in the correct order. There's no deadlock protection within Ubik itself, as there may be in other real database platforms. And it's slow. Part of the reason it's slow is because of the way that writes are propagated to all the other systems. So the time that it takes to perform a write is proportional to the RTT between all of the sync site and all of the non-sync sites. We have to do updates in parallel. Serially to each of the other replicated databases, and that has to happen multiple times. I believe Marcio is going to go into more detail about that as well. But the upshot is that writes are going to take a long time, especially if you have many members in the forum, or if they have high latency or are relatively geographically distributed. And synchronization is the same, even though it's in a well-configured cell with running on good hardware, good network. It's unusual to have a synchronization event occur where one server goes down and then it comes up later and you have to get a new version of the database. When that does happen, it happens synchronously. So nothing can happen within the cell and the other reads nor writes while a synchronization event is occurring. So if you have a large database and it's taking a long time to transmit, that also can have an impact on performance of the entire cell. These are the database servers, Ubik servers within OpenAFS. The top two, of course, everybody uses. You have to use them. We're familiar with those. Backup server, if you are using that, you may not even be aware that it has a database with it, but it does. It has to keep track of the backups themselves and what they're backups of, what dates they were taken, and things like that. The metadata about the backups are stored within that system. And kserver, of course, is obsolete, but that also was a database server, still is a database server. Okay, so inside of each database server, of course, whether it's a vlserver, ptserver, or one of the others we discussed, are going to be common components. And some of these belong to RX and some of them belong to Ubik. So this is above and beyond anything that the application itself might bring to the table. The vlserver, he has his own, maybe has some additional tasks, and ptserver might as well. But all of them have these things in common because these are pieces of either of Ubik itself or things that Ubik requires. The things that are the most interesting for the purposes of this talk, because this is just an introduction, is the beacon thread and the recovery thread. I'll be giving a little bit more detail about those things. But those are the ones that are really do the heavy lifting of making sure that Ubik works correctly and coordinates all of the different servers together. The beacon thread uses vote RPCs, so it's not exclusive to the beacon thread. You can use vote RPCs for other things. But that's the main user or main purpose would be there. And the disk RPCs are used by the recovery thread. Again, it's not exclusive to that. Other threads, of course, using disk RPCs, but the beacon thread and the recovery thread absolutely rely on those to do their work. So all of the coordination between the different machines is done by a special set of RPCs that have nothing to do with the RPCs that an end user would do to make a query against the vlserver or to read something from the ptserver. So if you are an Ubik server, let's say we have 3 servers within a vlserver quorum within a cell, and each of them has a different role within the cell. So because of the design of Ubik, which I'll get to in more detail in a few slides, there can only ever be one sync site elected within the group of servers that are participating in that cell. And how do we know which servers are participating in the cell? Well, we know that because they're defined in the subsystem. So that's the canonical list that all of the servers share. You don't ever try to run a cell with a ptserver or vlserver that don't all have the same subsystem DB. They will get pretty confused pretty fast. But only one of them can serve as the sync site at any given time. That role may move around between the 3 servers or the 5 servers, but there's only ever one at a time. The other servers will be non-sync sites. Sometimes you'll hear them referred to as clone sites. And the sync site works with them to make sure that they're still up, to update them when there's updates to the master copy, because writes always must go to the sync site first. And then the sync site coordinates distributing those updates to the other site. And that's part of what makes Rex take really one. What is that sometimes people forget about, it's kind of obscure, is that you can have a non-sync site or a clone that is called non-voting. And we'll see in a minute that that's kind of a misnomer. But the purpose of, well, I'm getting ahead of myself. These are the 3 roles. Any questions so far? Everybody hear me okay? All right. So let's talk about what the sync site does. You become the sync site by being elected by your peers. So one of the things that Ubik is designed to do is to run elections. And if you are already the sync site, then you run periodic elections every 15 seconds or so. And if you want to be the sync site for any reason, you also will start an election. And I'll give details about how the election works in a minute. But if you win the election, then you become the sync site. But if you're the only candidate, if there's only one DB server in the cell that can vote, then that site is automatically elected. In fact, there isn't even an election held in that case. It automatically becomes the sync site if there's only one server. So that's how a sync site becomes a sync site, and that's why it can move around. If that site should happen to go down, then another election will be held within a certain period of time by the remaining participants in the forum, and they will elect a new sync site from amongst themselves. The default sync site then is this DB server with the lowest IP address. It doesn't have to be that, that's just the way it's implemented. You have to have some way to pick somebody that's always going to be unique. That's always going to have an edge in winning the election. The sync site can accept both reads and writes. In fact, it's the only server that can accept writes. We often forget that it can accept reads. We think that it's only doing writes, so that's not really true. So if you have a cell that has really heavy read activity and also considerable amount of write activity, that read activity can have an impact on the performance of the sync site. What else? Oh, so I already mentioned that the sync site coordinates the elections. So that's kind of a cheat, isn't it? If you're already the chieftain and you get to run the election yourself, there's probably a pretty good chance that you're going to put your finger on the thumb and your thumb on the scale, and that it's going to be more likely that you win the election. And that is the case. That it's not because the sync server is necessarily cheating, but it's because the other servers that are participating will tend to vote for the one that's already sync site, unless they know of a better candidate, one that has a lower IP address. And we've heard from that recently, and they'll vote for that instead. But the tendency is to, once some site is the sync site, it'll continue to be the sync site until something bad happens. What else? It coordinates all of the writes and distributes distributed commits to all of the other servers. And it coordinates that process of making sure that each server also has a correct version of the database, and if not, to correct that situation. Okay. The non-sync site, what's he do? Well, first of all, how you become a non-sync site is very easy. You just lose an election. And then you're, by default, that's the default role, is that you're the non-sync site. So either you lose the election or you are voting for somebody else. You're not even running your own election. I refer to constant big time 75 seconds there. That's an important invariant or constant within OpenAFS Ubik that I'll talk about in a second. But the part of the role of the sync site is to keep the sync site in power by continuing to vote for him. And so Ubik doesn't work correctly unless the non-sync site is implemented to not vote for anybody else. Once he's voted for the sync site, it promises not to vote for anyone else for at least 75 seconds. So when we do lose quorum, when one of the members, when the sync site goes down, it can take up to 75 seconds or 80 seconds for a new sync site to be elected, because the other ones are holding back to wait to see if that sync site comes back or not before they'll start voting for someone else. And that's very important to make sure that only one sync site is ever elected at a time in the cell. Of course, it accepts only reads. If you send it a write, it'll fail with you not sync, and all of the code that does client calls to a vlserver, to a DB server, whether it be a vlserver or ptserver, knows that if it gets that particular error or you not sync error, that I'm just talking to the wrong guy, I need to try a different guy and try to find the sync site instead, because that's the only place where writes can happen. The last role is non-voting clone. Again, these are a little bit obscure, but this is how, if you wanted to have a non-voting clone, this is how you would do it. You'd issue a boss add host command, and when you specify the name of the new database server that you're adding, you enclose it in square brackets. That tells the system that this is a clone that is not going to participate in elections. And I'll give some more details about that in a second. But another way you can do that is if you don't want to use the boss add host command for whatever reason, you can also hard code it yourself within the cellservdb. So in the cellservdb, where you specify the names of the servers or the IP addresses of the servers that are going to participate in this cell, if you put one of them in square brackets, then that indicates that he's not a voting member. His vote don't count is the accurate way to describe that. So as I said in the next bullet there, then they do vote. They absolutely do vote, and even can run elections, their own elections, before Marcio made his fix that he's going to be talking about. But when the sync site receives their votes, he knows that they're non-voting members, and he just drops their votes on the ground. So that they're ignored, they're not counted. Can never be elected to sync site unless there's a certain edge condition that Marcia has been talking about, that a rare circumstance in which a non-voting clone could actually be elected as a sync site, and fix that. Same as with the regular non-sync sites, it can only accept reads, so they're going to fail the same way. And the purpose, why do I want one of these? I probably should have led with that, right? Why do I want one of these? The reason that you want this is because if you have a cell that is geographically distributed, widely geographically distributed, and you take the customary or traditional 3 members of that quorum and you distribute those geographically too, it's going to cause problems with the quorum. The cells work much better if there's low latency between the voting members of the quorum. So the purpose of having a non-voting clone allows you to have a local copy of the database at a remote site, and yet that site is not going to have a delay effect on election results. It still can have an effect on the time it takes to do updates and on the time it takes to do synchronizations if the synchronization event should occur. But the optimization of not having it participate in the elections or having its votes not delay elections, waiting for its votes, is important. That's an important function that it can provide. So say I've got a cell that's all over the world, and I want to base the 3 database servers in Europe, but I've got a site in Japan that has a number of file servers there and a number of clients there. You might want to provide a non-voting clone database in Japan for those, and then set the preferences of those clients to use that database server in preference to the other ones. Any questions about that before we move on? All right, so how do elections work? Well, I mentioned earlier that there were 2 housekeeping threads or background threads in Ubik servers that do the heavy lifting for maintaining all of these functions that we've been talking about. One of them, the beacon thread, is responsible for maintaining or coordinating elections. And so the sync site, or somebody that wants to be the sync site, will run an election, and the way that does that is it sends a vote beacon RPC to each of the other members in the quorum. And so to each of the members in the cell server, you bet it will user up. And then it does that using multi-RX, so they all go out at once. And it also indicates in the vote beacon payload whether it's currently the sync site or whether it just wants to be the sync site. And then all of the people that have received a vote beacon decide using an algorithm that I'm not going to go into in very much detail, will reply either yes, I'll vote for you, or no, I'm not voting for you. So a 0 means no, I'm not going to vote for you. But if they do want to vote for them, they send a copy of their local time right now back to the sync site, or to the site that's holding the election, I should say. Because remember, this may be this vote beacon may have come from a site that just wants to be the sync site. It's not actually the sync site. Ubik uses that to keep track of the local times on each of the servers, and is able to then make calculations internally for the validity of how long these election results are valid, based on the clock skew that's among all the people that have voted within this quorum. Something odd about this, if you're looking at a packet trace and are following an election, which happens every 15 minutes or so, every 15 seconds or so, you'll see the vote beacons go out, and then you'll see the results come back. And if that site doesn't vote for that particular server that wants to be sync site, they'll send back a 0, and that looks just like a normal response in the packet trace. But if they vote for that sync site, it's an abort packet, And the reason for that is because at a low level, even lower than Ubik, at RX level, if you respond to an RPC with a non-zero return code, that is turned into an abort at the RX level. So that doesn't concern the site that's running the election at all. It doesn't care that it looks like an abort. It actually is an abort. All he's interested in are the contents of the response to the return code. He interprets that return code as the timestamp of the server that sent that response. The first time, and I raise that because the first time I ever looked at a packet trace for this and was trying to debug a problem with form within at a particular site, and I'm seeing all these aborts, and I'm thinking, oh man, this is what's wrong right here. But there was nothing wrong. That's just the way it normally looks. Let me go back for a bit before I figure that out. Okay, so how do we tally up the results? Well, if you get a yes from a clone that's configured to be non-voting, we don't even tally those results. We just drop those results on the floor. It doesn't count. If you get a yes from a voting clone, it actually counts for 2 votes. And the person who is running the election also always votes for themselves, so they give themselves 2 votes. And then whether it's another person or whether it's myself, whoever has the lowest IP address of all the results that are received, that tallies 1 extra vote. So the results are, if the tally of the count of all of those results, if that tally is more than the number of servers that you got votes for, then, I'm sorry, the number of servers that are in the self-serve DB, then you win. If not, then nobody has won the election yet. So there is certainly a situation where if you have 3 servers in your self-serve DB and 2 of them are down, you're never going to get a sync site because that one site will keep running an election and will never get enough votes to win. He doesn't know that he's the only one anymore because self-serve DB says that he's not. Self-serve DB says that there's 3. So you'll never achieve more. So there's only a certain amount of resiliency that this protocol can provide. It's designed to keep on working, keep on allowing reads and writes to happen if 1 server goes down. But if 2 servers go down, then you're out of luck unless you have more than 3 database servers. Okay. This is kind of arcane, but this is the way that these numbers are determined. We'll look at on the next slide. But these are what these names mean, or what the semantics of each of these constants are. And I guess the ones that are important to us are that the polls are held every 15 seconds, and that's normal. So if you would happen to bump up the logging level on a database server, whether it be a vlserver or whatever, bump up the logging level past a certain point, I believe it's 5 from memory, then the log becomes very noisy because it's getting the results of the elections every 15 seconds. And some people just don't want to have long logs. They want to be able to do these things up for months or even years, and don't want to have to worry about large logs or rotating logs. And so most database servers tend to keep their logs at a relatively low level, either at 0 or at 1. And that can be a problem because there are some messages that you would really like to see for very unusual edge cases or problems within synchronization in particular that don't go to the log at that level when it's at that level. So there was a fix that that went into all the way from master back to 1.6 that improved the logging for certain problems within Ubik servers, so to make it easier to debug problems within synchronization events occur. The other thing that's really important to us here is this number right here. The algorithm doesn't work unless these numbers have a correct relationship to this number right here. It's defining the maximum skew that can happen within the cell is 10 seconds with that number defined with that value. And what that means is that it's your responsibility to make sure that all of the database servers within this Ubik collection don't differ from each other in their time base by more than 10 seconds. So of course, that is an implicit requirement for them all to be running on the same time base, and for that time base to be working well on all three of them. Very strange things will happen if a database server gets out of sync of time with the other ones, and it's very difficult to diagnose as well. So this is one area where I would consider that an Achilles heel of Ubik, is that it has this requirement. It's hard baked into the protocol, but it has no way of enforcing it really, or at least it does not enforce it. Let's put it that way. And so this is something that we have to be careful about when we configure these servers to make sure that the time bases are working correctly. Okay, so to ensure that I mentioned earlier that we are sure that only one site can ever be elected at a time as the sync site. These numbers and the relationships between them are the magic that makes that happen. As long as the system is obeying these relationships in the setting, the values that are assigned to those constants, then Ubik is guaranteed to work correctly. Big time must be bigger than small time, and the numbers that I showed you on the previous slide obey that relationship, and I've listed some other ones there. These last two, if you take a close look at this, you see that small time has to be greater than a certain sum, and then big time also has to be greater than the same sum. But we've already said that big time has to be bigger than small time. So one of these is redundant. But that's just the way they're phrased in the documentation. So the other thing that I'll say about that is that these last two relations actually both of them together, because as I said, they're redundant, they represent the same truth combined with the other one, is that it ensures that an RPC timeout won't interfere with our ability to maintain a form. Okay, I keep using this word. I don't think you know what that word means. So this is practicing. So quorum is the minimum number of votes required to elect a sync site, and that number is as implemented in the way the votes are tallied. That a yes vote is 2 votes, and an IP server, the lowest IP address gets an extra vote. The way that that's configured is designed to guarantee that there's always a majority are voting for the sync site, and that means that's quorum. And what we're really guaranteeing there is kind of subtle, but the fact that you have to have a majority of machines within the collection voting for a sync site, for one sync site, guarantees that at the next election cycle, if a different sync site is elected, at least one server that was in the previous quorum is also in this quorum. Very important implicit design decision that was made so to make recovery from a synchronization event easier. We know that somebody participated in the previous quorum, and so we know that we have a good copy of the database from the previous quorum. Okay. Once the sync site is elected, we have quorum, and this is true independent of whether all the members have a current database yet. So we have been talking so far about how elections are maintained and what the meaning of an election is, and how that is coordinated by the sync site work in the beacon thread. The beacon is the one that runs the elections. So the other database servers also run beacon thread, but it does relatively nothing unless it thinks that there's a problem and it has to run an election. Other than that, it doesn't really do anything. It's always there waiting, though, in case something should happen. It is always able to jump in at any time with a working beacon thread to become sync site if the need arises. The other thing that I'll say is that reads require neither quorum nor a current database version. So you can do reads against the members of the database. I think Marcia will probably talk about that a little bit more. But in order to do writes against the cell, you must have a sync site elected, of course, but also maybe a less obvious requirement is that you can't do writes unless everybody that's a current member of the quorum has the same version of the database. So this brings us back to that original comment I made a few slides ago, that Ubik doesn't know, Ubik is working with a physical database. It doesn't know anything about the contents of that database. It doesn't understand the semantics of a VL entry or a PT entry. It doesn't know anything about records. All it knows is a byte stream, and updates are always done physically. This offset for this length with this data. That's all that Ubik knows about. So the upshot of that is that if all updates are physical, then it doesn't work unless all three of them have the same content at the same physical offset in your database. That's where the requirement arises for having them all have the same database version. We want to ensure that each one, when we update a database on the three servers, the data at that same offset on all three is exactly the same before we update it and exactly the same after we update it. Otherwise, something has gone terribly wrong. All right, let's talk about the recovery thread for a little bit. The recovery thread is the other housekeeping or background daemon thread that I spoke about in a few slides ago. The purpose of this thread the recovery thread is, first of all, it doesn't have anything to do with synchronization for all of the servers. So this recovery thread does a little bit more than just recovery. For all of the roles, whether you be a sync site, a non-sync site, or an unrelated clone, all of them are running a recovery thread that at least does this first bullet point. And what it does is it maintains the internal state within your server of whether the other servers are up, down, or down from your point of view. So if they're reachable, then you think that they're still up, and you record that in an internal table. And that happens every 30 seconds or so. If you think that a server is down, let me just clarify that. Every 30 seconds or so, if you think that there's a server down, then you try to communicate with it. And if it's available, then you reestablish the canonical connections with it. And acknowledge that you're all part of the same forum again. That happens on all those things. That happens on all the sites, whether they're sync or not. The more important function of this recovery thread, which is to guide recovery when these synchronization events occur. And just to reiterate, what I mean when I say recovery or when I say a synchronization event is that one or more database services falling behind. They don't have the same version of the database anymore. So the role of the recovery thread is to fix it when it happens. And who can fix that? Only the sync site can fix that. Only the sync site should fix that. So this point of function in the recovery thread is only done by the sync site. The other sites skip this part. They just go back to the beginning and wait for another run through. So this happens every 4 seconds. It checks a global variable called the recovery state. And based on the state that it finds in the recovery variable, the recovery state variable, it decides what it needs to do. There's a state machine that it goes through. And once that state machine reaches its final steady state, then the cell is ready to do reads and writes. And up until that point, we are considered to be in a recovery situation. So if the sync site determines that it's in a state where it needs to do this work, the first thing that it will do is it will send a disk version RPC to all of the other members that it knows about and find out what version of the database they have. And compares the results from all that, picks the best one, the most recent one, and then if that version resides on his site, on the sync site already, it will go ahead and propagate that to the other ones. But if it determines that somebody else has the most recent version, then it will request that version from the other server using disk-get file RPC, and doesn't do anything else until it gets a complete copy of the latest version. Then after that point, if it has the latest, once that's finally completed, then it will propagate that to the others again with the same RPC that I mentioned before, the disk send file. So One key point about this is that it's all synchronous, and so nothing else can happen, no reads, no writes, while this process is occurring. But fortunately, in a well-configured cell with a good network, it doesn't happen very often. It should not happen at all. If these are happening frequently, you need to find out why it's happening and resolve the situation. One of the reasons it might happen is if you're doing periodic hygienic recycles of one or more servers within the database from time to time. You always go through a synchronization event when that happens. If you are bouncing the sync site in that cycle, then of course you're going to have to go through a synchronization. So, where was I going with this? Oh, that the fact that if you have a relatively large database or your connection with the other servers is high latency, then it might take some time to transmit that, and Andrew touched on that in his work, that when you're doing transferring volumes between servers, if they're far away, the latency has a huge effect on how long it's going to take and what the bandwidth's going to be. And the same is true for this as well. The other thing is that when the sync server has a current copy of the database, the most current version, and decides to propagate it to the other servers, it does not use multi to do that. It sends it to one that needs it, and then he sends it to the other one that needs it, and it does that serially. So that can take a long time as well. Yeah.
Sorry, do you remember, is there a reason we don't use multi there? Is it just maybe the complexity they didn't originally? Because it's auto-generated code, so I think it gets a little iffy, but it seems like we could.
It seems like we could, but I don't think it's that it didn't occur to them. I think it goes back to the simplicity thing. Is all I'm just speculating at this point.
That's what I'm saying. Is that it seems like it makes the code path more complicated because you have to because we conditionally do it to some sites. You have to build the array and then do it and then destroy the array.
Right.
Yeah, that's
so I think that's why. And if the synchronization code is already pretty ugly, it probably needs to be refactored. So.
As Marcia says, it's not beautiful.
No, it's not beautiful. Not beautiful at all. Okay, so I've been talking about this recovery state variable. Just briefly, this is geek stuff, but I like geeky stuff, so I put it in here. I like it. Just close your eyes for a second. But these are the meanings of the bits within that recovery state flag variable. And the first one with that particular value means I'm the sync site. The second one means I've sent out those disk version commands to each of the databases, and I've gotten replies back. So now I know which one's the best version. The next one is I've got a local copy of the best version. So it can set that right away if it determines already that I've already got the copy. But if it determines that somebody else has the best copy, it won't set the fourth bit, the rec_db, until that good copy has been transmitted from the other site and it has it on force. The next one is I've done my first write. So sometimes there is a considerable delay if you don't have many writes going on in your cell. It can be hours or even days before that bit gets turned on, and it doesn't mean that your cell is in that state. I referred to this earlier as a state machine. And so first you have to have that one, then that one, then that one. But this is one that is not required for everything to be okay. The next normal state would be this one. I've sent the best database to everyone, and then it will pause in that state until the first write occurs. So the upshot is that when you use the udebug command to look at this state, you would probably only be doing that if you thought there were problems between the numbers that you formed. Then if you saw that the recovery state is currently 1F, that's normal if there has been array activity. But there hasn't been a single write yet after the service has been down for a new election has results have erupted in your sync site. Then you might see a 1.7 in there, and that's okay. We'll panic when you see that. Okay, we're getting close to the end. If you are an administrator of a cell, you might be familiar with the udebug utility. Did I say utility? No, I didn't. I said utility. I hope. The utility is useful for determining sync site, diagnosing quorum issues. So the syntax is very simple. You just specify the server you want to get the state from, and you specify the port. So I'm going to test my memory here. I always get these mixed up. vlserver is 7002? And no? Yes? Mike doesn't know either.
That's PR is
2003.
The PR server is 7002? Okay.
BL 7003.
VL server is 7003. I always get them mixed up.
Yeah. Okay.
But you would direct it to the right server and to the right port to query the service and the machine that you're interested in. There is a long option. It doesn't do anything unless you send it to a non-sync server. The sync site, if you issue just the regular udebug command to a sync site, you'll always get the long information out of it. That's just by default. All right, so what's it look like? A lot of gobbledygook, but the things that we want to pay attention to here are this one right here, recovery state 1F. So that's what it looks like when everything's copacetic. If you see, ever look at this and you see a value other than 1.7 or 1F in there, then you know either there's just an election for some reason or one of your servers has just gone down, that you're in a state that you currently cannot do writes. And there's some other information here about what the other servers are doing, how the voting has been going, whether its database is current or not, whether this site thinks that that site is up or not. Lots of information here. The other thing I want to point out is this little obscure line right here, the time differential is 3 seconds. That's really the only indication that we can get from within OpenAFS of when there is some type of clock skew within your system. So all three of my DB servers in this cell are running on virtual machines. They're VMware virtual machines, not known for having accurate clocks if you're letting VMware keep the clock for you. And so that's why I've got a time differential there. Okay. Any questions about that? All right, next to the last slide. Best practices then for maintaining a database server is that you want to avoid connecting these voting servers over slow or unreliable WAN links. If you do need to have access to the content of a database at a remote site that does not have a good link to it, then consider making that copy a non-voting font. Always use an odd integer for your quorum set size. If you absolutely need to have 6 servers for business reasons, then make sure that an odd number of those are non-voting so that the actual numbers that are voting is an odd number. So with an even number, you're not able to ever achieve correct quorum. Unless everybody gets up. One goes down, you're not able to do it anymore, at least with 4. So make backup copies of your databases because boss stop does not shut down Ubik servers gracefully, or there aren't any signal handlers in the DB servers. Make sure that you run the utilities occasionally that check the integrity, the referential integrity of these databases, because there's nothing really in Ubik that guarantees that. Remember, that's not a database. We're just working with physical data. And so if you want to make sure that the logical data makes sense and is correct, the only way to do that is to run the application checkers. And PRDB check and VLDB check both do a thorough job of that. You can find problems relatively easily using them. And then if you do run into problems or you want to detect early when there might be problems, the utility is good for checking your configuration, making sure that all is healthy, all the servers have the same view of the other servers, the self-serve DBs are all correct and identical between the 3, and verifying that everything is operating correctly. If you are interested, there are some historical papers that you can find. If you do Google search for these, you'll be able to find these 3 papers. They're interesting, not just because of the background information it gives on some of the design decisions that are made for Ubik, that I came to that briefly in the beginning, but also for a historical point of view, just be aware that if you do read these papers, you'll learn a lot, but you also might be a little bit confused because early on, some different terminology was used rather than the terminology that we use today. For instance, I've been using the term sync site, and that term is not used consistently in these papers. There are some papers refer to it as a coordination site instead. And the names of the constants that I gave for the elections, some of those are different in this early paper as well. So just be aware of that if you read it. But it does do a better job than I did of comparing the reason why they chose to use Ubik rather than use the more well-known two-phase commit at that time. I can't remember if I said that or not. Yeah, I did say that at the beginning, that the reason they did not use an implementation of two-phase commit is because of the well-known restriction of two-phase commit. If that one member of the distributed system is down, writes are blocked completely, and Ubik skirts that restriction. It just does its guarantees of consistency in a different way that allows that restriction to be removed. Another thing that's really nice that I've mentioned in several talks now, I think, or I've heard it mentioned, that p-threaded Ubik is a thing, and originally came out in 1.4 or 1.6, but had considerable problems with it. The locking model just wasn't right. And so Jeff Hutzelman, who's a very, very learned expert in Ubik and all things OpenAFS, did a paper that is in the source tree if you want to look at it. At the very bottom of their doc text, Ubik text, does a very complete and accurate and helpful analysis of the internal blocking model within Ubik system. Not just the locking model, but how the locking model itself, but also how it protects each of the local and global state variables that participate in Ubik to make sure that the threading, that they're all thread safe. Excuse me, that they're all thread safe. So that's a very valuable paper as well. All right, that's all I had. Any questions? Yes. Go ahead.
You can go.
Go ahead, Bob. That says that you go first.
You want to go.
Okay. You take it. We had, do people use non-voting clones just for additional performance as opposed, for like locally as opposed to, I get latency, you don't want to use it.
That's a use case I'm aware of. Maybe there are others that I'm not aware of, but that's the one I think.
You use it for just performance, even though it's not a latency consideration.
Yeah.
You can set your clients to prefer.
He's saying, so you talked about using a non-voting clone to put it like near the sites because if they're geographically dispersed.
Right.
He's
I'm talking about
he's asking about if just 3 sites is not enough. Like you can't get enough transactions per second, so you add another site to get more transactions per second total.
Yeah, but that's going to slow down rights, propagation of rights.
Yeah.
Right. So,
Right. If you don't have a lot of rights, then you might actually be better in the long run for massive read volume.
Yes. So the question was, do people do that? Have you seen it?
I have not seen it, but that's a valid
the
idea.
number of people that use non-voting clones at all is probably very
Yes.
small.
Okay.
I've seen it done, but they've since moved to having separate cells now. When sites are small, when they have one cell, and you have a data center in California, and you have users in Boston, and it's like you don't have another cell, the users in Boston are hitting the vlservers in California. You can put a non-voting clone in Boston and have the clients point for that one.
Right.
But they weren't, they didn't have a lot of volume traffic. Since then they changed.
But we're not aware of it, but it's possible.
So we have a fourth non-voting clone in ourselves, but I saw your comment that when we shut down, we're not shutting down cleanly. The reason we had it was to do backups. So it sounds like our backups, it doesn't help us right in our backups. Because we're shutting down to take a backup on the fourth non-voting clone that's not published to the clients.
Okay.
So that's not helping us, I guess.
You can do it. You can do it that way. So, like when we say that we don't have any shutdown sequence, the servers are designed so that you should be able to kill them at any moment. And so the database on disk uses the log. So if you save the file and the log, then you give that to the database server later, it'll replay the log and have it in the system it should have a consistent version of the database.
So we don't need to stop to do that. We could just back up the file without stopping.
It's hard, but you need to, so we've talked about having like a command to like freeze the server or something while you make a copy or something like that. But you do need to at least stop the process because you have to grab 2 files and you can't do that. Like you can't grab all the data. If we're writing to the file as you grab it out, then it won't be consistent.
You say
So
stop,
you do
like T-stop, as
Yeah,
opposed
yeah.
to boss stop.
Yeah. So you could just send the stop signal to the process instead of killing it. But I mean, killing it is probably more normal, more expected operation.
So we have a force when we stop it and then we back up to the database and then we start it.
Yeah, so that, I mean, I do think that makes sense. We added a command, there's a command that some sites use called Ubik CP, which will read the Ubik data directly from a running server. We don't need to do that, like read it from files on disk, which is another way that people have been doing that kind of thing. So it reads the logical data.
Would there be any value in like adding a signal handler so you can stop it cleanly?
I don't know, I mean, the design is, the benefit of that is the way that it's designed is that even if, if you sig kill it because of like the killer or something else, it still works.
Still safe, yeah.
So it handles those cases. The only thing, like the real downside is just that it's weird when you're adding code and you want to have a shutdown sequence and there isn't one. But for the existing design of Ubik, I think it works fine. As long as there's no bugs. I think for around 10 years, the log was not read at all on x86 and little endian systems. So there are bugs in that. Yeah, so that's actually, I think, what caused a lot of corruption in people's Ubik databases that kind of seemed to appear and we didn't know why.
Mm.
That's why people recommend running those check commands like every so often to see if, the people just had this idea that cruft just builds up over time. I think a lot of it was that because we just didn't process the log.
Mm.
So where's Ubik CP? That's in Garrett now, isn't it?
What?
The Ubik CP stuff, or if they want to do a backup? Everyone uses
Yes, but there were discussions and possible objections to it, so it's not. I can understand that it's not merged.
Okay.
Other questions?
Just another comment. that
Sure.
We also use the clone function because we've been forced by our network teams to change networks multiple times and we want to control where the sync site is. So they'll give us a new network that's lower and we don't want the new servers on sync to become sync site until we've gotten all the clients updated. So if we get a new server on the new network, it's a clone, and when we get that in the cell server to be on all the clients, then we can go ahead and let it become master and then delete one or the other.
Yeah, I think Jeff
Okay,
wants
then
to-
you'll be very interested in what Marcio has to say about that.
Yeah, there was a change by Jeff Hutz submitted something where you could give a flag where it meant the server would not run for an election. Like even if it was a voting clone, it wouldn't try to become a sync site. So you could have a lowest IP and it wouldn't try to be things like for reasons like that. And it's always been discussed, I think, over the years to have some kind of alternate operating mode because sometimes lowest IP isn't good. But the trouble with that is you have to be very, very sure that all the sites are using the same criteria for who they want to vote for. Because if that gets screwed up, it really breaks things really badly. So having it just be like a configuration directive can actually be dangerous. Because if you misconfigure it, it breaks stuff immediately.
So when a client is submitting a write RPC, you said that at first it will contact any of the VL servers, and if it hits those, if it hits the non-sync site responds, "I'm not the sync site. Try again."
Yes.
And it'll retry until it reaches it. Will the client, if the client is submitting multiple write RPCs, does it remember which one? Does it cache the one that it thinks is the sync site to save a little? Maybe it's a negligible performance improvement, but is there any optimization there?
That information is stored, if I'm remembering correctly, that's stored in the uClient struct. And so the more complicated boss commands that do multiple writes, they're all internally using the same struct. And so yes, they do have memory that was the sync site and can use it.
Well, so I thought we always use the same site. Like we keep using the same site repeatedly until we get a problem or something.
So it's not just within a particular boss command, but across multiple boss commands.
Across multiple boss commands, no. It doesn't. If you've got your
file server, your file server that's running, that should remember it's,
Yes.
but if you're just running through the command line, boss move, boss daemon, that will start from scratch every time.
Yeah, if you have no persistent state.
Right.
But there is an optimization for that I have a patch for that I've never pushed upstream that allows you to define which RPCs require the sync site at build time, and then allow the clients to know immediately whether they need to sync site or not. Because even if you know what the sync site is ahead of time, when you submit the RPC, new RPC for the first time, it's not aware that it needs the sync site. So it doesn't know that the sync site is needed for this particular RPC until it gets a unit sync. And it's, oh, I guess I need to talk to the sync site instead. And only then will it consult whether it's a sync site or not. You don't want to consult that ahead of time because, again, you don't know whether this is a read RPC or write RPC. So the thing that I've written a patch for, that's determined at build time. And so at runtime, we know immediately whether I can just send it to the sync site if I know what it is already, or whether I can send it to anyone and not matter. So it doesn't make that much of a difference for performance because these things happen relatively quickly. But in the case of where you're doing a lot of writes, and it just reduces needless probes to the other servers. So really where it saves you is sending writes to the non-sync sites that it can't ever process. So why would you do that? It just impedes things.
Or if one of the sites is down, sometimes that makes something take, an extra 50 seconds.
Yes. Yeah, it might be a while before you find out, oh yeah, I guess I do really need sync. So that's annoying too. But knowing right from the start that you need sync, it can be a small optimization. Yeah.
Another question. So I think you mentioned it was in this presentation from yesterday. You mentioned something about how the VLDB is not a real database.
Yeah.
I'm not sure exactly what in what way, or what do you mean by that?
Well, it's not a relational database.
Oh, okay. Not a big kids database.
Yes, it's not a big database, right? Because big
I think
kid
that's
databases
implied,
cost
though.
big bucks back then when this was designed.
Because I would consider it a database.
It's a hierarchical.
Not a very
It's a hierarchical database. It's not a very good one either, but it is a hierarchical database. Yeah.
Just in the sense, even aside from the design, it's a place where you store some information that
Yeah.
you request over the network and the results back. So however it stores it to some kind of data.
There's nothing in the Ubik protocol that even understands the content of the data, and so it can't do referential integrity.
Yeah, well, that's what I'm saying. I understand the concept that Ubik is not, so that's VLDB
Yes.
is one that's implemented using a Ubik-like distribution system.
Yeah. Okay. Other questions or comments? All right, we're out of time.